Year 12 Examples Question 11.
Look at question 11. Okay. We have a circuit. In the circuit, we have three components, three devices. Okay. Light-dependent resistors. It's basically a variable resistor, but the intensity of the light changes the resistance of the resistor. Okay. We have a thermistor. The thermistor is the same thing. It's the same. It's a variable resistor. The resistance varies, depends on the temperature. Then we have a normal resistor here between A and B. So reading from the question, I know the voltage across the resistor will be 2.5 volts and 1 volts across the thermistor and 10 volts across 10 volts for the LDR, the light dependent resistor. Okay. Now I need to find the resistance of the resistor. So let's do this. The current is, just one more piece of information. The current is 0.005 amps. Okay. Now I need to find the resistance of resistor. So I know the current, I know the voltage, V equals to IR. Then put all the values in. Then I should have 500 ohms. Yep. So that's question A. Then look at question B. Okay. Now, that's in question B, they show me the property of the thermistor. Okay. Here's the temperature, here's the resistance. The temperature changes, the resistance changes depends on the temperature. So I need to find the temperature of the thermistor at that instant. It gave me, let's find the resistance first, because when I found the resistance of the thermistor, I found the temperature of the resistor. Okay? And we do the same thing, V equals to IR. Okay? So I know the voltage is going to be 1, the current doesn't change, it's a series circuit. The current doesn't split up. Now do the calculation, it's going to be 200 ohms. Okay. Looking at the graph, for resistance of 200 ohms, it must be 20 degrees. Okay. The temperature must be 20 degrees. Then we do question C. Now, in question C, it shows me the property of the light-dependent resistor. Okay. Again, the light intensity changes, the resistance changes. So if I put that device on the outdoors somewhere, okay, the resistance varies. The resistance changes depends on the light intensity, okay, whether it's day or night, whether it's sunny or not. Okay, so the question asks me to find the light intensity on that device at that instant. Okay. So the idea is, if I find the resistance, I find the light intensity. Okay. So if I look at the previous diagram, okay, the voltage across the LDR is going to be 10 volts. The current is the same. So let's do the math. 10 divided by 0.005. Okay. So I have 2000 ohms. Yep, it's going to be 2000 ohms. And if I look at the graph, 2000 ohms is basically 2k ohms, and 1k is 1000. So 2000 ohms, we look at the graph, the light intensity must be 15. Okay? And always remember, write down the unit. Okay? A number means, well, the value means nothing without a unit. So the unit says lux. Don't worry about what does it mean, but write down the unit. Okay. Well, lux is a measurement of the light intensity, but even in the exam, even if you don't know what does it mean, write down the unit. Okay, it's a unit of the light intensity. That's it.